Integrated Math 2. This is lessons 1.05 and 1.06 combined. And we are going to go ahead and start studying what are called right triangles. A right triangle is a triangle that has a 90-degree angle in it. So there are special formulas and properties that apply to right triangles. Let's go ahead and read a few notes. A right triangle has a 90-degree angle. This kind of angle between the floor, this is the kind of angle between the floor and the wall of this classroom. When you add the three angles of any triangle, doesn't matter whether 90 degrees or not, a 90-degree triangle or not, they equal 180 degrees. The Pythagorean theorem can be used to find the length of a side of a right triangle if the other two sides are known. The hypotenuse is the longest side of the right triangle. The formula for the Pythagorean theorem is a squared plus b squared equals c squared. In this formula, c must be the hypotenuse. It does not matter which side is a and which side is b. That's whichever one you choose is fine. Now there's a couple of special situations. An acute triangle, that's one where all three angles are less than 90 degrees. So an example would be a 60-degree, 60-degree, 60-degree triangle. All three angles are less than 90 degrees. They do add up to 180. So for an acute triangle, if a squared plus b squared is greater than c squared, then that means that's an acute triangle. An obtuse triangle has one angle greater than 90 degrees. So for example, a triangle with a 120 degree angle and two 30-degree angles, so 120 plus 30 would equal 180. That would be an obtuse triangle. And you can tell a triangle is obtuse if a squared plus b squared is less than c squared. A radical is a root, and in this assignment it's a square root. So generally you know what a square root is. It's referred to as a radical. It doesn't have to be a square root. It could be a cubed root or a fourth root or something like that. But in this assignment it's always going to be a square root. Okay, so let's move on and start doing some problems here. Okay, and it's not the camera that's blurry, it's the assignment that's blurry here a little bit. Alright, so here you have a right triangle. Right triangle is indicated by this little square in at one of the angles. That indicates that's a 90-degree angle, so it is a right triangle, so we can use the Pythagorean theorem. So what you have to do is identify which side is the hypotenuse, the long side. If you're not sure, because the sides might be fairly equal in length, it's always the side on the opposite side of the triangle from the right angle. So here's the right angle, and the side over here, the opposite, that's going to be the hypotenuse. So we can label this as hypotenuse, which equals side C. We said that the hypotenuse has to be side C. It doesn't matter which side is A or B. We'll call this A. We'll call this B. It doesn't matter. So what this means is that A squared plus B squared equals C squared. So A is the x here. That's our unknown. We're trying to find out the length of that side. So x squared plus b squared, which is 3. I'll leave off the km. That's for kilometers. Let's just leave that off for now. That's squared equals 4 squared. So we can simplify that and say x squared equals 9, with x squared plus 9 rather, equals 16. Now we can start simplifying. Subtract 9 from both sides, and that just goes away. 9 minus 9 is 0. So you have x squared equals 16 minus 9, which is 7. Alright, so how do we get x? You inverse x squared to get x. So the inverse of a square is a square root. So you take the square root of x squared, and that simply is going to equal x. Okay, let me prove that to you. If you take 2 squared, that equals 4. If you then take the square root of 4, it gets you back to 2. So if you take x and then square it, and then take the square root of x squared, it gets you back to x. If you take 4, or let me take 2 in my example, and you square it, you get 4. If you then take the square root of 4, it gets you back to 2 again. So that's the square root of x squared. So inverses simply mean they reverse each other. So that equals x. That means you have to take the square root of the other side, which is the square root of 7. And so the square root of x squared is x, and the square root of 7, we simply leave it as 7. Don't go on your calculator and figure out some decimal number. It says leave your answer in simplest radical form. So this is radical form. You don't have to go on and figure out that that's, I don't know what it is, 2.5 something, okay? It's just square root of 7. X equals square root of 7. Okay, let's keep going. So here's the hypotenuse opposite. So that's side C in our formula. Doesn't matter which side is A and B. We'll call this A, we'll call this B. So Pythagorean Theorem. So A is going to be X. B is going to be 7. And C is going to be 13. So X squared plus 7 squared is 49. Equals 13 squared, which is 169. Okay, we're going to subtract 49 from both sides. Those cancel. You have x equals 169 minus 49 is 120. And that should be x squared. I left the square off there. That should be x squared. So x squared equals the square root of 120. So if you take the square root of x squared, it simply gives you x, and that would be the square root of 120. Now we need to simplify this. So how do you do that? Whenever you have a square root, what you need to do is factor this, and you have to find out what the prime factors of this is. Those are the numbers that can't be reduced any further that multiply to 120. So we're going to start with 120. And pick any two numbers that multiply to 120. Let's say 4 and 30. So I'm going to come over here and put a 4. Come over here and put a 30. Now 4 can be broken down into what number times what number? Well, it would be 2 times 2. 2 and 2 are prime numbers, so we can't go any further on this side. Over here on the 30 side, we can have 5 times 6. And 6 can be broken down into 2 times 3. So all of these are prime numbers. You can't reduce them any further. So you just circle these. And that's equal to 120. All these numbers multiplied together equal 120. So that's going to be x equals the square root of 2 times 2 times 2 times 5 times 3. That's all these numbers that I circled over here. Now, to simplify a radical, you have to take anything that you can get out of the radical out. And the rule for this is pair them up and pull them out. So you find any two numbers that are the same here. You have a 2 and a 2. So 2 times 2 is 4, and the square root of 4 is 2. So this is going to equal 2 times the square root. Now once we pull these out, we have a 2, a 5, and a 3. Those don't pair up with anybody. There's no other 2 in there, there's no other 5, there's no other 3, so you have to leave them in there. So now you multiply them back together again. 2 times 5 is 10, times 3 is 30, so it's the square root of 30, and that's your final answer. Okay? So again, you have to factor. You find any pairs of numbers in a square root and you can pull them out. So 2 times 2, you pull them out, it becomes a single 2. In other words, 2 times 2 is the square root of 4. Square root of 4 is 2. So that comes out of the square root symbol and right there. So there is your final answer. Okay, let's keep going. This is C, it's the hypotenuse. We'll call this A, we'll call this B. So a squared plus b squared equals c squared. Okay, Okay, we're going to subtract 49 from both sides. Okay, and on this side it just goes away. You have x squared equals 256 minus 49, and that's going to be 207. Okay, so you take the square root of both sides, and on that side it simply equals x, and is the square root of 207. Now, does it have any factors? Can you break it down? You can. So let's go over here and do it. 207. 3 goes into 207. You know that 2 doesn't go into it because it's an odd number. But 3 does. 3 goes in 29 times. Okay, 29 is a prime number. You can't break that down any further. You can't break that down any further. So you can't pair up anything and pull it out. So there's no sense in even doing this. We didn't know that until we did it. But you get 2 prime numbers. Whoops, I didn't do that right. 3 goes into 207. It doesn't go in 29. It goes in 69 times. Okay. Now that does factor. Okay, because 69 would be 3 times 23. That would be 69. So, scratch this. So that equals the square root of 3 times 3 times 23. 23 is a prime number. You can't break that down any further. But here you have a pair, 3 times 3. So 3 times 3 is 9, and the square root of 9 is 3. So you pull the 3 out. So I'm going to come over here and do my final answer. So x equals 3 times the square root of 23. So you took these two 3's, you multiply them, you got 9. Square root of 9 is 3, so that comes out of the square root sign right there. And then you still have the 23 left inside, so there it is right there. And that's your final answer. Okay, number 4. I'm going to leave number 4 for you to do. It's exactly like the first 3. Number 5, some students found a little confusing. They weren't sure what to do with that square root, so let's go ahead and do that. So the long side is the hypotenuse. That's C. We're going to call this side A, this side B. Okay, so that's going to be A squared is x squared. B squared is 2 squared. It's a plus sign. And C squared is the square root of 13 squared. So remember what we said, a square root and a square inverse each other. They reverse each other. They basically cancel each other out. So all you end up on this side is 13. Again, let me give you an example. If I take the square root of 4, that equals 2. If I then take 2 and square it, it gets me back to 4. Okay? So that's an inverse. So what it means is if I take the square root of 4 and square it, I get 4. Alright, so if I take the square root of 13 and square it, I get 13. So x squared plus 4 equals 13. Subtract 4 from both sides. This side goes away. You have x squared equals 9. And that means that x equals 3. So that side right there is 3. Okay, that's how you do that. Okay, you go ahead and do number 4. It's like the first 3. All right, now we're getting into some that are going to ask us about whether the triangle is acute, obtuse, or right angle. So what we're simply going to do is figure out what a squared plus b squared is. We'll call this a squared. We'll call this a, and we'll call this side b, and the hypotenuse is c. So a squared plus b squared. What we're going to do is break up the formula. Equals, and then c squared equals. Okay, let's do c squared first. It's the hypotenuse. So c squared is the square root of 77, that's c, and then you square that, and just like in the last problem, that's going to equal 77. The square root and the square reverse each other. So you have 77 inside a square root, you then square it, you get 77. A squared plus b squared is going to be 5 squared plus 7 squared. That equals 25 plus 49, which equals 74. So a squared plus b squared is 74, c squared is 77. So a squared plus b squared is less than c squared. I'll go ahead and write the value down below. 74 is less than c squared, is less than this number right here, 77. Okay, so what did our rule say? It said if a squared and b squared are less than c squared, right there, then that's an obtuse triangle. So that means one of the angles is greater than 90 degrees. So we can just label that right here. And that's really the answer that they're looking for. What kind of triangle is it? It's an obtuse triangle. Okay, let's keep going. And I will do number 7 with you here. Let's see, that number 8 shouldn't be there really. Let's just say no problem so you're not confused. Okay, so let's do this one, same thing. So this is C, and again, it doesn't matter which side is A and B, so we're going to do that. So we're going to do a squared plus b squared first. So 8 squared is 64, and 49. So that's going to equal 113. Okay, 64, 113, yeah. C squared equals the square root of 113 squared. Again, you have an inverse, a square and a square root, so that equals 113. So they're equal. So a squared plus b squared equals c squared. I'll go ahead and put that down here, 113 and 113. So that is a right triangle. Okay, so that is a 90-degree angle. We could even draw it like that. Put that little square there, it's 90 degrees. Okay, we're going to keep going. You do number 7, so this is a U problem. I'm going to move on. Okay, now there's some special right triangles. And you'll come across these a lot in trigonometry, which is a subject we're going to get into in the next few lessons. One of them is a right triangle with two 45-degree angles. When the other angles other than the 90-degree are the same, that means the sides opposite them are the same. So notice this is an A and this is an A. Whatever this length is going to be the same distance. This length and this length are equal if they're opposite of 45-degree angles. It's also telling you that the hypotenuse, whatever side A is, the hypotenuse is going to be A times the square root of 2. So those are just known relationships for these special triangles. Over here we have a 30, 60, 90 triangle. So this is 90 degrees, this is 60 degrees, this is 30 degrees. That adds up to 180 degrees. So if this is the hypotenuse, the shorter of the two other sides is going to be half the length of the hypotenuse. So if this is 2A, this is A, or if this is A, the shortest side is A, then the hypotenuse is going to be twice that length. And the other guy, the other side that's not the shortest side, is going to be A times the square root of 3. So you take this number, multiply it by the square root of 3, and that will give you the longer of the two sides. That's not the hypotenuse. So it's just a relationship that's known for 30, 60, 90 triangle. So again, who cares about these special triangles? Why are they important? They'll come up a lot when we deal with trigonometry, which is a subject you're going to be getting into later. Okay, let's go ahead. So these are not problems here. These are just explanations of the relationship. So what they want you to do is solve the following problems using those relationships. Okay, so here we go. So this is a 90-degree angle. This is a 45-degree angle. That means this has to be a 45-degree angle. And we said that the sides opposite a 45-degree angle are the same. So here's a 45-degree angle. So if the side over here is 5, then the side over here, x, has to equal 5. Okay. And then we come back here, and each of these are the legs, so that would be 5 and 5 in the case of this. So the hypotenuse is going to be 5 times the square root of 2. So y equals 5 times the square root of 2. And that's all you have to do, just to understand that relationship. Okay? All right, we move on. Okay, here we have a 60-degree angle and a 90-degree angle. That means the other angle has to be 30 degrees. Okay, so what we said is, if this side is A, the short side, then the hypotenuse has to be 2A, and this has to be A times the square root of 3. Again, I'm just simply getting that off of this right here. The shortest side is A, the hypotenuse is 2A, and the other one is A times the square root of 3. So that's what I have right here. So we don't know what A and 2A is, but we know that this side here, and this side is going to be A times the square root of 3. Well, we see that this side is 7 times the square root of 3, so that means that A must equal 7. Okay, if this side has to be A times the square root of 3, and we see that the actual number is 7 times the square root of 3, then A has to equal 7. Okay, so that means this side over here is 7, because that side is equal to A, and this side is 2A, so that's 2 times 7, which equals 14. So this side you already knew, this side is 7, and this side is twice 7, which is 14. Okay, the last two problems I'm going to leave for you. This one is done exactly the same as this one, and number 12 is done exactly the same as number 9. Okay, so these are you problems. Okay, and there you go. So I'll leave those for you to do, and we will see you on the next lesson.